Hey guys, welcome to ANS Solver. Today we'll be doing the concept of integration by substitution, okay, which is a subtopic in the chapter of further integration. This is a very important concept. And before starting this chapter, you need to have the concept of logarithms, the concept of trigo, differentiation, and integration, crystal clear and solid strong, okay, because those chapters will be implemented here, okay. So yeah, let's start with the integration by substitution, the form first. How do you identify, okay, that you need to use integration by substitution? Okay, basically you'll have something like f of x into f dash of x, or you'll have something like f dash of x over f of x dx. This will be the form. Now let's have the example, okay, with 2x into e raised to x square dx with the limits 0 to 1. Okay, so now what you need to know here, okay, is that you can simply identify that x square here is your f of x, okay, and you can identify your 2x is basically your f dash of x. Okay, this is what you basically need to identify. Now what you do is you take a variable u and you equate it, okay, to the f of x. So you need to know that f of x is always equated to u. So you equate it to x square here. Okay, just give me 1 second. Sorry for the bad handwriting. Yeah, u is equal to x square. Now what you do is you calculate the du by dx, which is equal to the differentiation of x square, which is 2x. Now you can write this as du by 2x is equal to dx. Okay, so now what you need to do is you need to write everything in terms of x, correct? So what you do is, for now, you can deal with the limits in two ways. First, I'll tell you the first method, which is the easier method. Okay, then I'll explain you the other method also. Okay, so the first method is, because you're writing everything in terms of u now, these limits, which is 0 and 1, are in terms of x. Okay, so that means what you do first is you ignore those limits. You write this as the integration of, okay, you write this as 2x into e raised to, instead of x square, you write u, correct? And instead of dx, you write du by 2x. Now you can simply cancel the 2x and 2x. Now what you do is you write this as the integration of e raised to u du, correct? Now what you do is, as you have everything in terms of u, you integrate it in the terms of u. So the integration of e raised to u is e raised to u, correct? You don't write the plus c nor you write the limits. Now you convert this from u to x. You know that your u is equal to x square. So now you can write this as e raised to x square. And as you have written now everything in terms of x, you can write the limits, which is 0 and 1, correct? So write this as 0 and 1. Now in the place of x, put 1 first, which is the upper limit. So you get e raised to 1 minus, then put the lower limit, which is e raised to 0, correct? So you can write this as e minus e raised to 0, which is 1. So e minus 1 is basically your final answer in exact terms, correct? This is how you first identify, okay, your x square, or basically your f of x. You equate that to u, okay, differentiate it. Why do I take my f of x basically as u? So that when I differentiate it, I can basically cancel it, which we did in this step. So then I'll get everything in terms of u, correct? I integrate it in terms of u, then I change it to x, input the limits and get my answer. Now the other method, how you can deal with the limits, is basically, okay, this is called as limit conversion. You can use any. Okay, so basically you know that your u is equal to x square. Okay, that means basically you know your limit 1, your x is equal to 0, and you know your limit 2 your x is equal to 1. So what you basically do is, you write this as u equals to 0 square, which is equal to 0, okay, and you write this your u as 1 square, which is equal to 1. So in this case, as you can see, your u or your x and u limits are same, okay, but in some cases they are different, correct, which we'll even do in the example below. Okay, so now once you get these new limits, these are your new limits, okay, what you do is, you can simply, in this step where you're integrating, okay, you can simply write 0 and 1 here. Okay, these 0 and 1 are the new limits, not the old limits. Okay, so this was that example which I wanted to tell you. Okay, and then yeah, basically when you integrate, then you don't need to convert it to x again. Okay, you can just, simply just substitute and get your answer. But if you ask me for my personal choice, what I think is the first method which I taught you, where you ignore the limits and then input the limits, that's better. Okay, so that's what you can basically use. Now, what I can do is, I can give you another example here. So this was basically from a past paper, but I've modified it a little bit. Okay, so this is basically the integration, okay, of sine x over 1 plus cos x, correct, with the limits 1 over 3 pi and 1 over 2 pi dx. And I need to write the answer in the form of ln k. So what you need to do first is, I've told you, always take your denominator as your u. Take your u as 1 plus cos x. Correct? Now, what you do is, you can take your du by dx as the differentiation of 1 plus cos x. The differentiation of 1 is 0, and the differentiation of cos x is minus sin x. So you basically get du by dx as minus sin x. Correct? So you can basically write this as du by minus sin x equals to dx. Now, I've told you, first write everything in terms of u. So you ignore the limits. That's the best method actually, if you ask me personally. You can do that. Okay, and then later you can input the limits. That's the safest method. No need of converting again, and that's just extra working and extra effort for no reason. So first, ignore the limits and write this as sin x divided by, I can write 1 plus cos x as u, multiplied by, okay, I can write dx as du over minus sin x. Now what I can simply do is, I can cancel the sin x and the sin x. Correct? And I can take the minus outside. So I can write this as minus the integration of 1 over u du. Correct? Now I can write this as minus the integration of 1 over u, which is ln u. Correct? I can write it something like this. Okay, that's how we integrate first in terms of u. After the integration, we input the value of u. In this case, I have 1 plus cos x. So I can write this as minus ln 1 plus cos x, correct, with the limits, because now I've written everything in terms of x. So the limits I have is 1 over 3 pi and 1 over 2 pi. So I can write this as 1 over 2 pi and 1 over 3 pi. Okay, now what I can do is, I can write this as 1 minus, with ln, okay, 1 plus, first in the place of x, I can put half pi. So I can do cos half pi in the radian mode. When I do cos half pi, I get 0. Correct? Minus, I can do simply ln 1 plus cos 1 over 3 pi. Okay, so basically, just what you can do is, on the calc you can do cos 1 over 3 pi, okay, which will basically give you, okay, ln 1 plus half. This is what you'll basically get. Now what you can do is you can write this as minus, okay, here you will basically get ln1, sorry, just 1 second, yeah, here you can get ln1 minus here you will get ln 3 by 2, correct? This is what you'll basically get. As you know, ln1 is 0, so you basically get minus ln 3 by 2, correct? So you can basically write this as ln 3 by 2, which is basically your final answer. Okay, so this is basically the process of integration by substitution. Okay, so basically this concept needs a lot of practice, because the main thing is you need to get a judgment of what to take as your u, so that everything cancels. Okay, like we even saw in the previous example. Okay, so for that you need to practice a lot, especially for this concept. Okay, you need to practice a lot. And obviously when you're doing the past paper examples or the past paper questions, okay, even if you get stuck, you can view our video solutions which we provide and master this chapter, correct? Because there are many types of questions which they ask. Obviously we can't cover all the types. Okay, so basically just keep on practicing, because further integration as a full chapter also needs a lot of practice, and it's a very important chapter, correct? So thank you very much. See you all in the next video. Thank you.